Hello, Math Champions. In this video, we're going to learn the next topic about equivalent fractions. In the previous video, when we learned about ordering of fractions in ascending order, we talked about something called equivalent fractions. Now, first we'll understand what is equivalent fractions, and then we'll see how we can use it for various different addition of fractions, ordering of fractions, all those things. Okay. First of all, we have heard about something called equal. Equal means we know it is like one is equal to one, right? So equal means it is same. Now, what is equivalent? Equivalent means equal in value. Equal in value. That is the meaning of equivalent. Now, let's take one of the fractions. Let's take half. Okay. If you see this is one half, totally became one whole, right? This all of this is, let's say this entire thing is one whole. But when I talk about only this is called 1/7. This much is 2/7. So this goes like that, right? Now let me take only one half. Now we see this orange color thing. This is one half. The white color thing is one half. Let's take only the orange color. Can we find any other fractions which, like, if in this, can I reduce it in such a way that it will be equal to the length of this one half? No, I can't do that. Can I do in this one? Let's see. Okay. If you see what is happening, this and this, these two are having the same length of colored shape. Maybe even in this, two parts are there, fine. In this, one part is there, fine, which is colored. But however, the total length of colored part is same. Can we find similarly like that in other pieces also? See, we found this, right? This much. See, if you see this one, this one, this one, all are having equal sized colored parts, right? Let's find this. Okay, this also it happens. Can we do in this? No, this extra, little extra, or this is less. So this is not going to help. Okay, if we do this one, okay, this much it comes. Okay, and in this we got this much. Now let's name all these fractions. Okay, let's name all these fractions. This is one half. Then this is 2/4. Then this is 3/6. Then this is 4/8. Right? Only I'm taking the colored part. Then this is 5/10. Then this is the last one is 6/12. You see, all of these are equal in value. Though they look, let the numbers like one half, 2/4, the numbers look different, but they are equal in value. That means one half is equal to 2/4. One half is equal to 2/4. That is equal to 3/6, and that is equal to 4/8, and that is equal to 5/10, and that is equal to 6/12. Now, when you see all these things, are you seeing any pattern here? Yeah, there's a pattern here. 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12. There's a pattern happening there. What is the meaning? So here, I am multiplying by 2. I got this. If I multiply this by 2, I'm getting this. Right? If I take another one, let's compare the first one, this one, and the second, this one. If I'm multiplying 1 with the 3, I'm getting 3. If I'm multiplying the 2 with the 3, I'm again getting a 6. So, if I multiply a same number to the numerator as well as the denominator, I get an equivalent fraction. Now, taking the same number, can I find other equivalent fractions? Yes. Say, for example, I multiply a 12 here and a 12 here. I'll get a 12 over 24. So, we can say 12 by 24 is also a equivalent fraction of one half. Okay. So, we could do multiplication. Can we do division and see? Let's see. Okay. Let's start from 6 by 12, right? We know that is a equivalent fraction, right? Can I get one half from the 6/12? How can I get? Can I divide this with the same number? So I can divide the 6 with the 6. And even the denominator I'm dividing, the with the same number 6. Then I will get 1/2. So how do we obtain equivalent fractions? That is by dividing or multiplying the same number from the numerator and denominator. What is the meaning of this? Okay, what is the meaning of this multiplication? Let me tell you what is the meaning. So now we have this 1/2, right? 1/2 and this 2/4. What is the meaning of this, like multiplying by 2? Is nothing but every part. Say for example, this part is there, this part is there. I'm going to cut this every part into 2 pieces. When I do that, it comes same as this. See, it comes as same as this. Now if I do this, this is 1/4, this is 1/4, this is 1/4, this is 1/4. The entire whole is cut into 4 pieces and 2 pieces are colored. 2/4 I'm getting. So that is the meaning. Now, can I find let's say a 2/3 is there. 2/3 is there here. Okay, I'm making it 2/3. Can I find equivalent fractions for this? For that, what I can do is, see, I can cut this, let's say, into 4 pieces. One part into 4 pieces. Let me do one part into 4 pieces. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now, I did every piece, I cut into 4 parts, right? So, I got total number of pieces is 12. Okay. And in that, how many are colored? 4 here and 4 here. So, 8. So, 8/12. That means 2/3 is equivalent to 8/12. Let's see 8/12. Here is our 12. So let's get it at 8/12. If you see here, what is happening? I will just draw and show you here. If you see here, the length of this and this is equal. The 2/3 was equal in length to 8/12. And we could also get it by that. What is the connection? Every part I was cutting it into 4 pieces. That means I'm actually multiplying by 4. So every part I'm cutting into 4 pieces, and that is why the total number of parts also increases by like 4 times, and even the numerator, the selected parts, also increases by 4 times. So I get 8/12. So this is the meaning of multiplication. Now, using this concept, okay, let's compare or order fractions. Let's take some fractions and see whether we can do it in ascending order. Once we know ascending order, we can tell which is lesser, which is greater, all of these, right? So let's take one example and understand how we can use equivalent fractions to help us to do ascending order. Now, let's take like 2/3, 1/4, 3/12, 2/6. Okay. So I'm having these many fractions. So in the previous video, I showed you that you cannot just, take it as numbers and then compare. Like you cannot say 3 is less than 4 and 4 is less than 12. And you cannot do that kind of thing because fraction is about shapes, right? About shapes. So we will use shapes and understood how to do the ascending and descending order. However, now we will use the concept of equivalent fractions. Now, equivalent fractions, if you see, all these denominators are all different, right? So can we make all of these denominators equal? Same. So now, can we get like 4 multiplied by something? Can I get 12? I can get 6 multiplied by 12 also. 6 multiplied by something also I can get 12. So this is the 12 is the LCM of all of these. So first I will find LCM of all the denominators, right? 3, 4, 12, 6. For all of this, the lowest common multiple is 12. So I'm going to select the 12 as the thing that I'm going to use. So as of now, 12 itself is there here. So this fraction I don't have to change. Now I'm going to change this fraction in a form such that I'll get a 12 in the denominator. How can I get a 12 in the denominator? 1 by 4 is there and I wanted 12 in the denominator. So what should I be multiplying it with? I should be multiplying with 3. So when we do equivalent fractions, we have to multiply the same number with the numerator as well. Then only it will be equal in value. So this is 312, right? That means 1/4 is same as 312. Let's see here. Okay. 1/4, right? Let's see here. 1/4, 1/4 and 312. Let's compare only these two. 1/4 and 312. Look at that. Look at that thing. It is exactly the colored section is exactly same in length. So 1/4 is equal to 312. That means instead of in the place of 1/4, I can write 312. Okay, I can write 312. How about the next one? I want to change this to 12. So 6 times 2 will give me a 12. So 2 times 2. Same number of times I have to increase. 2 times 2 will be a 4. Okay. And here again, I wanted what is a 12? That means 3 times 4 is a 12. That means 2 times 4 is a 8. So now this 2/4 is 2/3 is same as 8/12. 2/6 is same as 4/12. It's like that. Now all of these fractions, I have written some equal value of it, but now all the denominators are same. Now, what did we learn in the previous video? When the denominators are same, now we can just compare, and see which is equal, which is like, which we can just compare the numerators and then decide the smallest one. If you see the 312, you have got 312 for two things. That means 1/4 is the same as 312. That's the least one. Then the next one is 4/12. 4/12 means actually 2/6 we are talking about. Then 8/12, which is nothing but 2/3. So this is the ascending order of the fractions that we got. So what is the procedure? Let's understand again. And not only the procedure, we also understand what is the logic behind it. When fractions are given with different denominators, we cannot compare them because they are talking about different shapes. And fractions are shapes. So we cannot do them directly. But when the denominators are all same, okay, that means, say, 312, of course, is less than 4/12. 4/12 is less than 8/12, right? So it becomes easy for us. 3/12 is less than 4/12. 4/12 is less than 8/12. It is easier to compare when the denominators are same. So whatever fractions are given, we'll take the denominators and find the LCM for all the denominators joined together. Okay. So that why we are doing this? So that a multiple of 3 should be 12. Multiple of 4 also should be 12. Multiple of 6 also should be 12. So I should be able to get a multiple equal to the same multiple for all the fractions. And that's how I found 12 is a common multiple for all of them. So now I am going to convert every fraction into the fraction which has the lowest common multiple as the denominator. Once I've done that, all the denominators will be same and the numerators will vary. Now, based on the varying numerators, I can decide which is the smallest one, which is the greatest one. And in this way, we can find out the ordering of fractions also, even when the denominators are not same. And for this, we have used the concept of equivalent fractions. When the denominators are not same, we use the concept of equivalent fractions. Equivalent fractions is also useful for us when we are going to learn about addition and subtraction of fractions. Let's see that in the next video. Until then, bye-bye.